Okay, welcome to another episode. In the last episode, we went through the theoretical background on how to deal with physics practical. But today, we're picking a WAEC practical question and we'll go through every step, especially plotting the graph, choosing scale, and answering the question that follows. So sit back with your pen, your book, and get your hands ready to join me as we go in this journey of understanding physics practical. But before we go further, don't forget to like and subscribe, and then click on that notification button so that you can get every of our educational content. So let's dive into this question. So this is the question that we'll be solving. So we have a diagram from here. You are provided with a pendulum bulb, a meter rule, a stopwatch, a retort stand with a clamp, and other necessary apparatus. Suspend the pendulum bulb from the clamp as illustrated in the diagram. Adjust the pendulum bulb, the pendulum such that AC, you can see the AC here, equals to L is 90 centimeter. Displace the pendulum bulb slightly such that it oscillates in a vertical plane. By vertical plane, up and down. It oscillates in a vertical plane up and down. So you measure and record the time T for 20 complete oscillation. Take note, you can take this twice and get the mean value. And then evaluate T and the square root of L. Repeat the procedure for 4 other values of L, 80, 70, 60, and 50 centimeters. Tabulate your reading. Then plot a graph with T on the vertical axis and the square root of L on the horizontal axis. Determine the slope S of the graph and evaluate G equals to 4 pi square over S square. State the precaution taken to ensure accurate results. Determine from your graph the period of oscillation. Determine from your graph the period of oscillation. Determine for your graph the period of oscillation. State two precautions taken to ensure accurate results, and determine from your graph the period of pendulum for length L equals to 75. A simple pendulum ball is said. So this is theoretical questions that you need to answer. So far, this is the question that we will need to answer. So let's get set for that. So these are the, we've read the instructions and what we are required to do. If we look at how do you have your tables of values, very important because that's what you use to plot your graph. How do you get your table of value? The table of value. If I'll be underlining some things that will guide you into seeing the things that you have to include in your table of values. Okay, let's come back. Suspend the pendulum bulb from, so we can say adjust the pendulum such that the length, so length will be very important for your table of value. And then displaces, then oscillates in a vertical plane, and measure and record the time T. T is very important for your small t, which is the time taken, total time, and then evaluate T. For us to evaluate, that means this also should be part, and also this should also be part of our table. So we have how many? I think that's all that we need to include in our table. So we have 1, 2, 3, 4. So 4 column or 5 column. So the 5th column may be for the numbers. So we have the numbering, how many experiments that we are taking. So we are completing how many? The first is 90, 80, 70, 60. So we have 5 of them. So 1, 2, 3, 4, and 5. So mostly the first row where you have the table headings should be this is the general form of how the table should look like. So we have 4 others. So 1, 2, 3. Make sure your lines are straight. I'm not using ruler. 4, 1, 2. So yeah, something like that. Okay, yeah. Now, remember from our last video, you have to name it correctly. L first, and what is the unit? It's they are given in centimeter. Put it in bracket. T is in second. The unit is in second. Then we have capital T, and that capital T is the small t divided by 20, since we have 20 oscillations, and the unit is in seconds. And then finally, we have the square root of L. The unit is centimeter half. There's no minus here, just 1/2. Then you perform the first when the length is 90. You set it into a vertical oscillation, and we need 20 oscillation. Record the time for 20 oscillation. Let's say the time for 20 oscillation is 38 seconds. So the period will be 38 divided by 20. That is 1.9. I'm putting it through decimal places because of the accuracy of the instrument. This is also to 2 decimal places. So the square root of 90 should be 9.49. So this is 80. Go to the next one, 80. Record the time for 20 oscillation. Make sure they are well aligned. And then get the period that's divided by 20, 1.80. Well aligned. Then get the 8.494. Align them. Then move to 70. Record the time taken for 20 oscillation is 34. Let's say it's 34. So let's get the period divided by 20. 1.70. Make sure it's aligned. And then square root of L is, make sure. Then here it's moved to 60. Let's say it's 32 here. Then it's 1.50 and 1.50 should be 1.60 here. So here should be 7.73. And the last one is 50. So see, they should be straight. Make sure they are straight. 30. So 1.50 and 7.07. So these are table of value. I've gotten the table of value. Oh, and that's exactly what we have here. Let me put it at 6. Yeah. So the next thing, and you have to pay attention very closely here. You need to pay attention here. You need to pay attention here. So give your graph a title. The graph is what? Plot a graph of t on the vertical axis, and so graph of title, graph of t against, sometimes may use versus dt or t square, graph of t against root L, graph of t against root L, graph of t against root L. Okay. The next thing is, let's choose our scale. Let's choose our scale. That scale is on which question? Determine this, plot a graph with GGD. So scale will be that VII. So let's choose our scale here. So VII scale. So we are choosing the scale for the y-axis and the scale for the x-axis. So let's say, now how do you, this is very important, and I want you to be very attentive here. I have some rules for choosing the right scale. Now let's count how many boxes we have in the y-axis. Normally, for your the graph you'll be given, you have like 12 on the vertical axis, 12 of this 2 centimeter. This 4 is 2 centimeter. 12 of this 2 centimeter, 1, 2, 1. Let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So normally you have 12, and here the horizontal, you have 8 of those. Now I'm using the 2 centimeter. So I'm using the 2 centimeter now. So let's choose the scale. So on the y-axis, what are we plotting on the y-axis? According to the instruction in the graph, we're plotting a graph of t on the vertical axis. Vertical axis is the horizontal, and the y-axis. So on the t-axis, on the y-axis, so let's see the maximum value there. Let's look at the t-axis. The maximum value there is 1.9. 1.90. Okay, so out of these 12 2 centimeter boxes, let's say we want to use 10 of them. So I'm dividing the 1.90 divided by 10. So I'll have like 0.19. Good, but I can't use this. It's not it's not a good scale. So I can get an approximate. I can use like 0.2. So I can use 1 centimeter, can use 2 centimeter to represent 0.2 units, or 1 centimeter to represent 0.1 unit. It's very, very correct. So I'm coming here, on the y-axis, 2 centimeter represents 0.2 units. Then let's go to the x-axis, which is the horizontal axis, we are getting the square root of L. So square root of L, the x-axis. So let's look at the maximum value there. The maximum value is 9.49. So maximum value is 9.49. So since we have like 10 of those 2 centimeter boxes on the x-axis, let's say we want to use 8 of them. So 1 will be 9.49 divided by 8. Let's use the calculator to do that. So 9.49 divided by 8. We have 1.186. 1.186. So what do we do? Yeah, 1.186. How do we do this approximation to get a good scale? So we can use it to be, let's say, 2 centimeter, can approximate it to be 1.0. Yeah. So we can say 2 centimeter to represent is 1.0 units. You can see, so I'm coming back to my scale on x-axis. On x-axis, two centimeter represent 1 unit. 1 unit. That's what it means. Okay, so having gotten that, we can now plot our graph. So let's draw our line. Let me make this smaller. So use your ruler and draw your vertical line. So I'm using black. Should be straight. I'm using my hand. Okay, let me use the ruler. And then So draw my line so I can start selecting these points. So I have when L is equals to, so when L is equals to 90, no, when T is equals to 1.90. So let's label the axis before we pick. This is the T axis. See, and put the units, and this is the square root of L axis. Like that. So label it, and that is the origin must start from 0. So let's start getting our point. So when we have one, now since for 2 centimeters we have 10 of these tiny boxes. So that means for the y-axis, each tiny box, the tiniest tiny box is 0.2 divided by 10. That's 0.02. Each tiny box. And for the x-axis, the same thing. We divide it by 2 by 10. So I have tiny box there will be 1.0 divided by 10 with 0.01 or 0.1, sorry, 0.1. So that's mean the tiniest box is this. And for you to get the actual point, let's get the number of boxes. Now you have 1.90. It's easier to locate 1.90 on the t-axis. So let's label. Let's use our scale. Since our scale is 2 centimeters to 0.2 unit, so we are starting here. This is 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0. That's all. Then let's transfer. Here we have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and 0.9. So when T is 1.9, so this root L will be 9.49. Sorry, mistake here. So let's correct that. For here, the scale is 2 centimeter represents 1 unit. So let's correct that. 2 centimeter represents 1 unit. So we are writing 1. This is 2, 3, 4, 5, 6, 7, 8, 9. So 1.0, 2.0, 4.0, 5.0, 6.0, 8.0, and 9.0. Like that. So when T is 1.9, where is 1.9? This is 1.9. L is 9.49. 9.49. So 9.49. So 9, this is 9. 9.1, 9.2, 9.3, 9.4. Almost at 9.5. So I put it at 9.49. So here, so I prefer to use the cross So this is, can trace it, can use a ruler and trace the point like this, and mark the points like this, like this, like this. So it matches this. Trace it down. Forgotten one. Then we'll move to the next one. 1.8 to 8.9. This is 1.8 to 8.94. 8.94. Where is 8.94? This is 8.94. This is 8.9. So 8.94. Somewhere at the middle. So somewhere here. Should be somewhere at the middle here. Then we'll move to the next one. 1.7, 8.37, 1.7. When it is 1.7, we have 8.37. This is 1.9, 1.8. It's 1.8 here. So 1.8, 8.37, 8.37. So this is 9. This is 8. So 8.3, 1, 2, 3, 37 is almost at 4. So we'll mark it here. Mark it there. Then we move to the next. 1.5 and 1.67. This is 1.6. Take note. 1.6 is 7.73. So this is 1.6. And then this is 8. This is 7. 1.6. 7. 7.73. 7.1. 7.2. 7.5. 7.6. 7.7. So somewhere like this. Then the last 1.5 and 7.07. This is 7 was 1.5. This is, and then 0.07 just before. So we've marked our point. So now we can draw the line of best fits. Can join the line of best fits from here. From here, pass it through it. So that's the line of best fit. Excellent. That's the line of best fit. Then you can move to the next. Determine the slope. Ix. Number your work. Ix. Number it there. So you have to draw a large triangle. To get your line of best fits. Large triangle. So for me, I'm using this. Let me pick a point that's very easy to locate. Very easy point. Let me see. Yeah, it's easy for me. Like this. A large one. Very easy, the place that is very easy. Yeah, yes, okay. Let me arrange it where. Let me not use this. Let me just use my free hand. I'm picking this line here. This line here. So let me even choose, I'm choosing this point. This point is way easy for me to locate. Yeah, here is way easy for me. So I can pick it like this. Make sure you use your ruler. Yeah. So I can trace it to this place. I can trace it here. Use your ruler to trace it up and down. Tracing it. Tracing it. So this is the x2, x1, y2, and y1 towards the y-axis. So what number is that? I mean the slope x, that's ix, so I can write ix slope equals to y2 minus y1 over x2 minus x1, or you can use the t2 minus t1 using and the square root of L2 minus square root of L1. Anyone goes. So T2 is what we have our Y2. That is 1. You can see, you can trace it here to here. We have 1.7. So I write 1.7 there. Minus, go to T1. You can see it's easy for me to locate. Here is 0.8. So there was a mistake in this labeling here, which needs to be corrected. This place here, this 1.0, this 1.0, this place there's mistake here, so it has to be in the correct order. So let's correct that. But let me shift this first. So here it's supposed to be 1.0, 1.2, 1.4, 1.6, 1.7. This is where 1.8 is supposed to be. So that means we will need to redo our line of best fit because of that error. I need to erase all this. So you have to be careful. Thank God that this mistake was made. So and you have to be careful. Thank God you saw the mistake. You have to correct every mistake. Thank God we made this mistake so we can see where mistakes have been made. Okay, so let's get back to the line of best fit. So what do you know? Yeah, you're supposed to extend it. This is 1.8 here. So somewhere like this. Then 8.95 and 1.7. So here's 1.9, right? So of course it gets to another mistake. So here's supposed to be, let's go back to 0 0.2, 0 0.4, 0 0.6, 0 0.8, 1.0, 1.2, 1.1, 1.6 here. Okay, here is 1.8. Yeah, here is 2.0. Excellent. So correct every error. 2.0. So here will be 1.9. Yeah. Then, oh, so 1.8 and 8.94. This is 8, 1.8, 8.94. This is 4, 1, 2, 3, 4. 4 is somewhere here. This is 8, 8 point. This is 9. This is 8. Let's see, this is 9. This is 9. This is 8. So 8.94. 8.9. Somewhere like this. So the first one. See if, let's relabel. Yeah, because our axis has shifted. So label it. Let me label it. Okay. You have 1, 2.0, 3.0, 4.0, 5.0, 6.0, 7.0, 8.0, and 9.0. So good. So 9.49. Yeah, that is there. Then we have now we have 8.94. This is 9. This is 8, 8.94. Somewhere almost 9, 13 to 5. Then we have 1.7, 1.7, 8.37. This is T. This is 9. This is 8, 8.37. This is 3, 1, 2, 3. Let me say almost here. Then we got to 1.6, 7.73. 1.6, 7.73, 1.6. This is 8. This 7, 1 point. Okay, this is 7, 7.735, 6, 7. Somewhere around here. Then we have 1.5, 1.5, and 7.0, so almost 1. So I can draw the line of best fit now. Use this line of best fit. Pass through. think so. That's the line. Best fit. Then we can then draw our, pick any point. Very easy point. Choose your scale. Looking for the best point. Okay. Let me pick this point. Very easy. So let me pick this point here. Let me pick another easy point, very easy point. Easy, no ambiguity. Here, 2 points. I can draw a vertical line from the top one. Don't mind my line. It's just easy. I can get my slope from here. So this is my trace here. This is my y2, y1, x2, x1. So I trace x1 to this place, and y2 to this place, and y1, this, and then good. So I can go back to my do my, so y2, which is t2, is now 1.62. 1.62. So I write 1.62. T1 is here 0.8. With L1 is here. That is what? That's 8.0 minus, yep, 3.5. So if I use my calculator, 1.62 minus 1.62 minus 0.8, I'll have 0.82 over 8.0 divided by 3.5 was 2.257. So I can do my 0.82 divided by that. I have 35, so I'm getting 35 centimeters. So it's 35.875. What should be the unit? This is time over square root of length. The unit should be time over the square root of length. That can say second something like that. So that is the slope that we have, second per centimeter. So let's move to the next thing. The next question is saying, evaluate the value of G. We're given the formula to evaluate the value of G. That's 4 pi square over x square. It's from the question. But if it's not given, let's say it's not given. So if it's not given, we transform the equation. But since this is given, we have t squared we've been given that g equals to 4 pi square over x square. 4 pi square over x square. 4 pi square x is 0.35.875. So what we should have there should be 4 35.875 squared. Is 0.0307 centimeter per second. So you can multiply it by 100 to get 3.07 meter per second squared. So that is the value of G there. But normally, so sometimes the equation will not be given to you. Sometimes the equation, this formula is not given, but you can do the transformation. So for the transformation, we know that t equals to 2 pi square root of L over G. And the graph is t against square root of L. So can rearrange it 2 pi square root of L and the square root of G. So can I 2 pi square root of G square root of L. So this is the y-axis and this is the x-axis. So if we compare it now with y equals to mx plus c will be 0. Normally, our graph is supposed to pass through the origin. Then 6, 0, then t, that means the intercept is this. So m, which is the slope, let's say slope equals to 2 pi over g. For the equation, we're given that slope is s, so let's say s. There is square root here. So that means the square root of g equals to 2 pi over the slope. If we square both sides, g equals to 4 pi square over x squared. So that's how the formula there was gotten. So you can use it to get the value of G. So the value of G there is 3.07 meter per second squared. Any question? So let's see the next question. Evaluate, state the precautions taken So you can write the precautions that are taken. One of the major precautions is to avoid zero error. Another precaution is to avoid error due to parallax when taking reading. And then you have to ensure that the support was rigid or firm. So those are the major precautions that you need. So the other question, determine from your graph the period of the pendulum for L equals 75. So go to the length L, 75 centimeter. So you get the square root of 75 centimeter. Get the square root of 75 because you are plotting on the graph, you have square root of L. So you get the square root of 75 centimeter. Square root of 75 centimeter is 8.66. So I have 8.66 here. Then you go to your graph and locate 8.66. This is 8.6, somewhere like this, and trace it up. Trace it up. Trace it up, trace it up. Trace it up until where it touches the graph. Trace it up. Your outline you must use a ruler. My hand is shaking. So this is where it touches the graph. Then you trace it to the time axis. Trace it to the time axis. So I have like 1.72467. So 1.77. So the value of T there is 1.77. Okay. Then the other one is calculation. So I'll leave down for you to do on your own. So this is where we end the series for today. I hope you enjoyed the class. Kindly like, subscribe, and click your notification button for more engaging content. Thank you.